Welcome back. So today I want to do a couple of things with this video. First of all, I have found this program called GitKranken, and I'm running the free version of this. And it is a front end. It's a graphical front end for GitHub, and so we can open a repo up here. This is my Auto3 repo. This is the code for my voice activated assistant, and I started this, as you can see, a year ago, and I didn't touch it for many months. I created the first couple of files and didn't do very much with it. But I want to show you that if I want to look at this first commit, I click on it, and here are the two files that are in that were in that repository at that time. And so this is very simple. I created this talk to me program here, or I'm sorry, this is a function, talk to me function, and I was using the say command, which has a not very good voice. This speech recognition program code is primarily from let me pull up let me pull this up here and show you. Actually, probably the easiest way to get to is PiPI. PiPI speech recognition. Here we go. So PiPI is a project that curates a lot of Python modules. They get put in here, and there's a description of them and how to install them usually, and things of that sort. And so one of the things you can find here is the source code. And if you come to PiPI and you click on the source code, you're going to get the official repository for that code. As you probably know, you can fork a repository. Then there'll be another speech recognition under someone else's name, and that person can modify the code in good or bad ways, and you don't know. It's always best to go to the official repository. And look here, this has got almost 5,000 stars. It's watched by 271 people. So this is a pretty popular repository, and this code has been, I consider anything that's been used by this many people, looked at by this many people, to be fairly well vetted. Anyway, there's an example directory here. And let's see, this is the microphone recognition.py. So if you look at this, you'll see that most of the code that is in, most of the code, I'll put it on this side here, most of the code that's in here from the example file is what you're going to find in here. This is the very first version of this that I worked on, and so there aren't very many differences. But this example here is meant to be a very simple implementation of for using this module. It's about as simple as you can get. And what we can do here is we can take a look. So here, for example, if we go in here, we can see what's different from the last commit. So what's in red here, this is stuff that was removed. And what's in green is what was added. So looks like I made a typo here. I'm not sure what's going on there. But you'll see that I define talk to me to use a variable text rather than audio, because that's what gets passed to talk to me is text. It doesn't get past audio. This is text to speech. So it's taking text and then it's going to produce audio. So I found that the example actually had that backwards, and I thought it was confusing. It was going to confuse others. So this is the kind of thing that we can improve in these repositories. Probably this is something that deserves a pull request, which is a request to the original maintainer to make that change in the code, but I'm not going to bother with that. And then down here, we see that we are switching from the play command to GTTS-CLI, which is Google's implementation of text-to-speech, which has a much, much better voice. And you'll see later on we're going to switch from MP3, from play to MPG123, which is also, I consider it to be a better player. And if you want to look at the full file here, you can look at the full file and not just the diff. This is the changes that were made from the last version. And this shows the complete file view. So really what this program allows one to do is go to a complicated repository and follow along the thought processes of the programmer. From the initial simple version that probably came from some example somewhere else up to their full-blown implementation. And you learn quite a bit this way. You learn how programmers refactor their code, what modules they discard, and which ones they change to. You can go off to Google then and find out more about a particular module maybe you didn't know about at all. So you'll notice I've got some funny commit messages here. If it's just a typo or something like that I fix, I actually use an alias that I've loaded, which downloads a random commit message. It's actually it's YOLO. If I say YOLO and then the file name, it will commit it with a random message. So that's why some strange stuff is in here. So I do things like, where is it again? I was going to make a comment on something and then I scrolled past it. Oh, here we go. So here I've just added some, I put an URL in my comments to an article that I thought was pretty good about Amyl. I had some, Amyl is a chatbot engine, and Amyl Files are a good way to share little snippets of chat that you can curate Amyl Files and get an interesting chatbot that way. But I don't know, I played with it for a while. I wasn't that interested. Eventually I ended up taking this out of my code altogether. It's a little toy. And I want something that's a little more serious than that. I want something that's actually useful and helpful. But so you follow along here. You see me switching programs, switching to MPG 123, for example, putting in new modules. Making grammatical changes to the comments to make it read better. Removing unnecessary stuff, cleaning up the code, things like that. All right, so let's get down here to the end here, because I really want to look at, I want to show you some changes that I've made here. Where is this? Let's go to the file view. And you'll see that I've commented out all of these imports, because I'm not going to use Pocket Sphinx, and I'm not going to use the speech recognition module anymore. So, this is interesting, because this is the module that started the project. And so I guess this was how old? 4 or 5 years old? Let's take a look at that. See if they have the date on that. Oops. I've never looked for the date before. All right, maybe here. Well, in 2017, they were already on version 3.8. It looks like it started up in 2014, so that means that this is a 6-year-old program already. And it's a great program. I have nothing but good things to say about it. But now, as you can see, I've decided to stop using it. Why? I stopped using it because it doesn't know about vost and kaldi. So you'll see here that there is a new import statement down here from vost import model, kaldi recognizer. Now, I think that you'll notice that we don't have to import the vost API, and we don't have to import kaldi. It seems to me that kaldi is how you would create a model. to recognize speech. But we have a model here. And so we only need the kaldi recognizer in order to, and I'm not sure where this is bundled. There is a way that we can try to find this out, how this is sitting on the system. I think it's the dir command inside of Python that we can figure this out. But I don't want to go down that rabbit hole right now. What I do want to do, I haven't implemented this wake word as a variable, and actually this probably should be made a not a variable, but a constant. But I haven't implemented it yet, and I'm probably going to make it Julie like this. Anyway, this code here is just checking to see if the model exists. See, all this is going to be removed. This is all that stuff for the chatbot. This is the talk to me using GTTS. I still haven't found anything better than that. All of this stuff here is going to go away. This saves synthesized speech to audio. I'm not going to have to do this anymore because I don't need a wake word and a to pass this along to Google. I think it's good enough. I think I'm just going to use vost and kaldi for speech recognition. I don't think I'm going to be sending anything out to Google. So here's the speech to text function, and I think that it's gotten quite a bit shorter. So we make an object, a Pi audio object here, P, and then we open it up as a stream, and then we start the stream, and then we set our model variable, and then we call the kaldi recognizer and pass it the model, and this is the 16 hertz, I think that's how you say it. 16 hertz is the size of the wave format we're going to be using. And then we're going to read, what is that, 2,000 bytes, I guess. And then if it's 0, we don't do anything. That means the microphone's not working. We break. If the this is the kaldi recognizer object, we ask it to accept the waveform. This is the method we call, and we pass the data. So this is that 2,000 bytes of data. And then we get a result from that. This is still that same rec object, and it has a result method, and we pass that to a variable called myResult. And myResult is a string, and then we break that up into a list on the word text. So if you watched my previous video, you would have seen that when their test under mic.py program ran, and that's where I got this code here, or I got the idea for this code was from that file. Once again, just like with speech recognition, I was starting from an example. That had a big multi-line string in it that it spit out, and at the bottom it had the completed result, and it said text colon, and then the completed result showed up. So what this is doing is it's splitting that string into two parts, that big multi-line string. Everything to the left of text and including text, everything to the left of text but not including text is going to be my list braces 0. Everything to the right of text but not including text is going to be my list brace 1. Right? That's a my list. So here we go. We're accessing the second member of the list here and putting it into command, and then we're returning it. And then we go through this stuff here. If open Reddit in command, then we do this stuff here. If YouTube in command, we do this stuff. If dictation in command, we do this stuff. But that's it. That's the only bit of code necessary for doing speech recognition. It's very little. That and the initial import statement up at the top here. Import vost. And of course you have to set the system up first in order to do this, which means you have to install, you have to do a pip install of vost, and you also have to get the model and untar it, and you have to install, well, you don't have to, I don't think you have to install vost-API, but vost-API is where the example files are. So, and that's out on GitHub. I cloned that. I don't know if you have to install kaldi. The reason I don't know is because I have kaldi installed. I suspect that this will work without installing kaldi. It's probably not necessary. But I mean, it's like most things having to do with artificial intelligence. You need programs to build a model, but then once you have the model, you no longer need that software. You run that with something else, or with a piece of that program. So as I said, I don't know if when I did the git install of vost, did I get the kaldi recognizer with that? That's the question. And I'll try to answer that at some point. But in the meantime, I just wanted to show you this really excellent program, in my opinion. Go ahead and save that. This is a wonderful way to go through a repository. And I've been, let me see if I can close this one here. Oh, here it is up here. I still don't know this interface very well. I've been going through this one here, Melissa Core. And this is a very, very complicated program. So if we look at all the files here, there are a lot of files, there are a lot of directories, and so on. And so if you want to learn what this program does, how do you even start? What's the main file here? All right, is it setup.py? Right, these are all directories here, so maybe it's in here. But where? Where might it be if it's in there? Or is it in setup? Is it in tests? So this is very complicated. To understand this repository is going to be tough, But if you come down here, the birth of Melissa, it's got two files. It's got main.py and a license file. And if we look at this file here, lo and behold, what do we find? You recognize this? Oh, I do, because this where is it? This is this. So this particular repository started out with the same example file. And you can see that as they move through this, they've worked on some performance issues. I mean, it didn't change very much here. They added some quotes. You know, these are 3 new modules were added, so you can take a look at these very quickly. All right, let's take a look at the diff view here. So just put these 3 modules in here, right? And otherwise it's pretty much the same. They had already changed to this check message function that replaced that big if then else with their own big if then else function. But you know, if you look further back in the commits, you can see where that happened. And then you know, they refactor the code over here. But look, it's growing. Now we have more files here. So they've added a database. They have created this brain file where they have taken a lot of the logic, all of the logic that has to do with this big if then else file, and they've stuck it in its own file. They've taken it out of the main.py, and instead they import it. So if you have a Python file in the same directory as the file that you want to run, you can just import it, and then all the functions that are inside that other Python file become available. Not the main code that's in it, but the functions. They're all available. And so if we look at this file here, we see an import statement and then a definition for a function called brain. And that's it. There's no code. There's no code in here that calls brain. If we look in main.py, we call brain here, and we pass it all of these variables. So now normally what you would see inside of a module like this is if dunder main, if dunder name equals dunder main, then try, and then it would have main or something like this in here. But this programmer hasn't gotten to that yet, hasn't learned that, but we'll probably see that later on. So that way, this could also be used as a module. if it had that in there. Or it could be used as a main program. But I'm getting a little bit off track, but I thought this was interesting enough. Here we see we have the gray matter directory, right? And this has Python files in it, but these Python files are not in the same directory as the main.py. So you can't import them unless you put a dunderinit.py file in the directory. Now there's nothing in this file. It's completely empty, but it's there and it has to be there. Once you add this in here, these all become callable modules. And so you'll see back here in the main file, well, let me just do this. Back here in main, it says from gray matter, import play music from gray matter. Sensecells.tts, import TTS, text to speech. So that logic, the text to speech logic, has been moved out to its own file, and it's being called here. It's made a module, and it's being called here. And this is good coding practice. This is what we want to do. We don't want to have a 3,000 line program. We'd rather have it be modular, so we can work on the modules individually. It makes it easier to understand the program. However, if you're looking at this for the first time, it's not easier. It's very difficult to figure out where things are and what they're doing. So this GitKranken program is really, really very, very helpful for this. And we can just follow this all the way up here. And what I'm most interested in actually is, let me see. At some point, they put this inside of a Flask app, and it's really beautiful the way they do it, and that's what I'm interested in. And I'm going to find, all right, so they're using templates here, so that means that they're using a Flask app at this point. So maybe about here. I don't see anything here yet, but all right, so this looks like it might be the first file with templates. And so this individual here, Rachmaninoff Hariono, he has, I guess, designed the front end for this, the Flask front end for this, and at this point it's merged in, and it may be that at this point it's fairly far along. So what I'm going to do is I'm going to look for Rachmaninoff Hariono's, probably, it sounds maybe Japanese, I don't know, although this sounds Indian. But I'm going to find his repository, and I apologize to the gentleman if he watches this and I mispronounced his name. I'm going to look for his repository for Melissa Core, and I'm going to go back through and find his journey, his programming journey, and try to follow it. Anyway, that is GitKranken. At least that's how I'm using it right now. This is a program which I'm sure has tremendous functionality, and I don't understand it, I don't know it, but I do know this much about it, and this is extremely, extremely helpful, and it's free. This version is free. It's licensed for use on open source projects. So and if I didn't have this, I would have to go from the command line and check out all of these different versions and pull them and look at them and then get rid of them. It would be a huge pain in the neck. This just makes it so easy to do this. And I've also found that on my own repositories it's very good for making branches and squashing code and that kind of thing. But I really don't know very much about it yet. It is a tool I plan to learn more about because I think it's going to be more and more helpful as I progress on my own journey. Anyway, I thank you very much for joining me, and I hope you've enjoyed this, and I hope that you learned something. Thank you very much.